So I'm opening up the Recording Historic Structures, which is on Oaks. Yep, there it is, and here you have it. I'll make it full screen, and we'll be referring to that during the course of this discussion. Okay, so it's John Burns' book that was the basis of it, but essentially what we're looking at is trying to tailor it to where we are. John Burns wrote a book called Recording Historic Structures, so that's kind of where we are. So anyway, sorry, interference with telephones and everything else here. We're looking at trying to develop field work and measure drawings. Those of you who had 215 will be working on historical reports. Also looking at potential preservation issues. Those of you interested in more the technical side of it. We'll be looking at details assessment, and then your final project essentially will be mostly a design in this case, or a planning and design effort, dealing with the streetscape and the buildings along George Street as unfinished business here. So basically what we're doing is working on George Street. A little bit of background though for the overall process is that we're looking at developing documentation styles that relate to stuff that's been done before by the Historic American Building Survey, the Engineering Record, and the Landscape Survey. This has been going on since the 1930s, and it's been very useful to try for us to understand our built heritage and to be able to respond appropriately. It's been helpful for us to, keep organized about this effort. Back to this. Just a note about archives. We do this in a formalistic way. If it goes up to Washington and goes part of the archive there, then there's a 500-year storage facility. So you can see that a lot of digital media, sometimes a little conservative because of the concern that some of the media is untested. In any case, what they end up preserving are drawings, which will, on Mylar and put in the right circumstances, which will last according to their requirements for archiving. We don't need to go into a history too much because those of you who've taken 215 have probably already had this, but I'm going to jump to the historic building format, which basically lists it, as you can see here, by 3 parts, plus an introduction. Introduction just giving, as you see here, location, owner, use, and significance, real quick. There's a halves number. And then you divide it up into 3 parts: historical information, architectural information, and then sources of information. Historical information also acts as a bit of an introduction, and you deal with the things that you see there, date of erection, architect, and so forth, as much as we know. And then given historical context. In this case, looking at George Street, we're looking probably at the maps. The relevant maps would all be the Sanborn maps, starting about 1888 or so and going on till about 1940, to talk about how this street has changed. We also have architectural information, which deals with the character and condition, as well as you can see, the various aspects of the exterior, the interior, and the site. And then finally, you're looking at sources of information, which give you an opportunity to write about those kinds of things and also talk about what you haven't been able to get into, unfinished, research, so that the next person picks it up. I guess that highlights the fact that historical reports are probably never really finished, and we're trying to make the best we can out of it. You notice that this is done in a particular outline format. This is an expanded outline format. Call it a database if you want to, where each item is listed in the same order with the same kind of outline format, so that if you're looking for information, you know where to find it. It's not just a narrative, otherwise everything gets lost in the narrative and its chances are it will be incomplete. So this is the kind of outline format we'll be working on. Those of you who choose to do such a report for the buildings around in here. There are a couple of significant buildings which we can talk about as we go through here. I guess I should point out that the Rivers building on the corner of St. Philip's and George Street is probably the most significant building. But then there's also the Cistern, of course, the most significant building that's undergoing change right now. But there are several other historical buildings, and of course the Cistern green along through here, and we want to make room for discussion about the modern structures and their relationship to the streetscape, so we'll be blocking those out as well as doing detailed drawings of them. Photography, you can see that this photography portion of it was set up for rather old-looking cameras. These are 250-pound cameras, bellow cameras with larger negatives, which is really the standard that HABS uses for archiving photos, again, looking at that 500-year time frame. We'll obviously need to be using digital cameras, SLR cameras. The main thing is you'll be able to get your pictures back on a format that you can read on the computer and not just on your phone. So we're basically trying to provide good documentary photos that we can use not only for documenting, but also for your use in the studio to remember everything that you see. These are basic kinds of comments about taking good pictures and trying to develop different kinds of pictures. And so this is a good way for me to kind of jump into the idea that there are 3 different kinds of photos you're taking. One is elevational photos, where you're, as this illustration on the top shows, about halfway along the building and halfway up if at all possible, to try to get the building face on, front on, which is really useful for sketching in your hand drawings and your CAD drawings. The next one is a character kind of photograph, which is taken at the corners, so that it gives you how things come together, how roofs come together, and so forth. And then lastly, we take photos for details, where we zoom in on certain features of the building and take them. Those are the basic 3 kinds of photographs. There are other kinds of specialty photographs, which we'll talk about here in just a minute, but these illustrations give you a sense of how those kinds of pictures are made. Here's the overall photograph showing you as you back up from the site on an elevational basis on the left, how much of the building you see and what kind of photograph it is, from a detail of the porch to the landscape or the whole building in the middle. The one on the right shows you resolution of the photographs and how, by taking it at an angle, you can see how things come together better than with an elevation. Specialized techniques in photography include rectified photography. Of course, rectified means fix. That essentially means fixing it so that you can use it as an elevation or for your particular drawing purpose. You can see down at the bottom there's a photograph that's been rectified for elevations, and you can see the lines have lined it up so that it has also been scaled, so that essentially you can trace that. It's worth noting on this photograph, though, that you'll notice as you move away from that one plane that's outlined there with the pencil lines, that things get smaller because it's still a perspective. Things are smaller the farther they move away from you. So that roof is actually a gable roof, even though at first glance, if you think this is an elevational photograph, it looks like a hipped roof. No, that's just the nature of perspective. You also see other kinds of specialized photography, including stereophotogrammetry, which is essentially usually used for aerial photos to show dimensionality, to show 3D aspects. X-ray cameras, which are used to see what's inside of things, are not all that popular anymore because it requires ISO certification, and it's not the safest thing in the world, but is occasionally still used. Lastly are infrared photographs, which are interesting because, as the name implies, it measures heat index. And depending on how you scale the heat index, as you can see on the left of this upper photograph, you can get different color resolutions to show you what is hot or what is cold. The image you see there on the top is obviously of a fuse box that's becoming overheated, and you can see that as it's been taken apart on the right. On the bottom, you see an elevation of a building with different colorations that are showing differences in temperature, which is indicating intrusions of moisture. So you can see there's a variety of uses that infrared photographs can be used, and they're exploring more and more all the time, including using infrared to detect species, composition of wood, and so forth, but I'm afraid those are very preliminary and need to be done under very highly specialized laboratory conditions. Also with photographs, you can see it's not always easy to get everything you need in one photograph. The one on the left is trying to take an elevation in the back, and you can see the addition on the side kind of gets in the way of that, so you actually need to take another picture of that and then stitch them together. I've got examples of how to do that online as a PowerPoint, and of course I can review that with you in class when you take these photographs, but the point is sometimes you have to take more than one in order to get a good elevation. On the right, you see an example of just the difficulties of taking photographs with vegetation that's in the way, and occasionally you just have to do the best you can with that. Also, the perspective, these 2 photographs are basically showing you character sketches, but they're really all that's available because the walls or the buildings are in the way and you really can't take elevational. So photography is very much a practice in what's possible here. All right, photography and history. Now we're talking about measured drawings, which is essentially what we'll be doing in this course. Of course, what's different about this course is that we're starting with a sketch to try to capture a sense of the historic character of that place. And so this is a little bit different, and I hope will be more appealing in the sense that it'll get you into the space before you get involved in the more arcane aspects of drafting. But without getting into detail here, because like I say, we're not taking a midterm test here. We're basically just trying to understand what we need to proceed and getting some general background information. The measured drawings you see on the right show you on the top a sectional or a cutaway of that building, and it's an engineering kind of thing. You're looking at a water wheel and looking at all the machinery that operates on 3 levels, and that really can be shown most effectively with a sectional drawing rather than, a plan or an elevation per se. A section, again, is a cutaway of the structure. On the bottom you see an axonometric drawing. That's axonimetric. There are different kinds: isometric, like an isosceles triangle at 30-60, or axiometric, which is various angles based on what you're trying to show. But the point of the axonometric drawing, it's a way to show plan and elevation to scale, both at the same time, as opposed to a perspective drawing, which, as we said earlier, the size diminishes the further you get away and therefore is not to scale. So these 2 drawings show specialized techniques that are particularly appropriate in engineering. These basically are just talking about methodologies, which we'll talk about as we get out in the field, but we're starting with sketches, as I said before. These are examples of a plan and an elevation done in a graduate studio, so it's far more detail than we'll get involved with, but shows you a kind of sketch that has detail in it. And that's something maybe a little bit different. That shows a particular kind of level of detail based on the kinds of drawings that you're doing. Now I have some examples coming up that show you basic details for doing a plan drawing, which is essentially what you'll be doing until you get into the detail phase. But this gives you a sense of it. Now in this regard, you'll notice that there are a couple of features which I would refer you to the handout. The handout that is online, if I can find it. Downloads, I think I've got it here under Hab's Guides to Field Documentation, which is also on your OAPS page, which gets us to looking at, these are molding details shown on the cover, but in here is a description of sketching plans and elevations, which might be useful to you. Again, this is on a graduate level, so a little bit more detail than what you're looking at. And as we look at what's on here, we can see references to all kinds of things, but I'm looking for, you can see how they do plans on the inside. They don't get into a lot of detail because we're only drawing this at quarter scale, but they show enough that you can do some dimensions to show some of those details in general, and then go refer to details, photographs and or drawings to show more information. Plans and elevations are shown here. It's interesting. You notice the gridded sheet seems to help you get things straight. And then you see on here exactly what I'm looking at. What we're trying to do here is develop a kind of recording which is called a running dimension format, using what I call a dot format, essentially is a 3-number format. Running dimension essentially is what it says. You start at a 0 point and then you move forward until the end point. And then you record dimensions along the way that accumulate to the top, to the very top. As you can see on this line down here at the bottom, it goes from 0 to 4 inches to 11.9, 3.25, 14.42. They accumulate. They're not just this distance between, but they start from 0 each time and work out. This is one way to keep from having to take up and put down the measuring stick, and it makes for more accuracy, and is the accepted protocol. Now, you'll notice these numbers are written in kind of a funny format with the 040, 1193, and so forth. This is what I referred to earlier as the dot style, where the first number is the foot, the second number is the inches, and the third number is the quarter inches. And we usually dimension this only to the nearest quarter, so this in plan is usually just indicating 0 quarters or 3 quarters or 2 quarters, or call it a ½ inch here. So 040 is 0 feet 4 inches. 1193 is 11 feet 9 3/4 inches, and so forth. This is a way that actually makes it easier to add and subtract these numbers once you get back into the office and be able to use them more readily. It also makes for greater accuracy in the field and makes it quicker actually to do your dimensioning. I'll give you examples of how to add and subtract this once we look at this. It's a bit awkward in this format for me to try to do that. That's really what I wanted to show you here under this, but the rest of this just bears generally looking at with a view towards saying, okay, we're not going to take it to this level of detail, but there's some stuff in here we can certainly use from time to time as we're trying to do our measured drawings, and it'll be useful for future. Now back to here, where we're looking at the PowerPoint. Hello. There we go. Like I say, plan and elevation showing you a level of detail for sketching. Now what we have